Hello, I'll be talking about the MC1R protein. I'll introduce it first. The subcellular location for this protein is a cell membrane. The connection to a condition is that causes beach mice to have lighter fur color. The mutation is arginine 67 is replaced by cysteine R67C. So this is my model for the protein and the mutation. I decided this would be the mutation and then this would be the normal one, and I'll describe why. So the MC1R is a 7 transmembrane domain GPCR, meaning it has 7 A helix regions that span the cell membrane. The extracellular portions interact with signaling molecules like a MSH, while the intracellular portions interact with G proteins that regulate melanin production. So the materials I used to mimic this would be the pipe cleaners, mimic the A helix. The beads represent the mutation, and I'll show this better. The beads here at the bottom between the second and the third helix. The red one would be the mutation, and I used the blue one here. And then the membrane layer, the foam board to show the positioning of the plasma membrane. So this protein does not contain any subunits. And then MC1R has primary, secondary, tertiary, and quaternary structures. And how I represented these in the model were the primary. I used a string of a bead, with different colors to represent the amino acids. This would be here at the bottom, and then here. Sorry, I apologize. That would be the second one is the mutation. Then the pipe cleaners would be the helixes, the 7 different ones. The tertiary would be the assembling the helix in the form within the membrane together. And then the fourth, the quaternary, would be the showing of the interaction with signaling proteins here at the bottom, the intracellular interaction. So I decided to build 2 separate models to show where the mutation occurs, one in normal protein and then one in the mutated protein, with the different beads being the difference between them, the mutation, the arginine, the R, and the cysteine C at position 67, which would be here in both, alters the local structure. The R is a positively charged hydrophilic amino acid, while C is a smaller uncharged capable of forming dulcified bonds. This charge may cause local structure instability or lead to misfolding of the receptor, reducing its ability to interact with the MSH. So the function of a normal MC1R is that it binds to AMCH, activating a signaling pathway that increases in melanin, which is the dark production. The effect of the mutation is that the mutation of a R67C is that it disrupts the MC1R mutation, reducing its ability to activate CAMP signaling. This leads to less melanin and more phenolmelanin, which is a lighter pigmentation. This results in the lighter coat color that provides the camouflage for the beach mice. So I used to highlight the 67 position and the different color in the primary model was the bead, and to differentiate between the R and the C that reside in the secondary and tertiary structure of the model. And then I made the 2 models to demonstrate the effect of the mutation, with the bead being the difference. And the limitations of my model would be that it has a lack of dynamic motion, limited detail to it, atomic level, and membrane environment not accurately represented. Just because this is a very simple model, this would not show realistically the helixes as complex as they are in a normal protein, and it would be way more complicated than this, and this is very simplified based on my model. I hope this explained it well. Thank you.